Sir, we will wait for 2-3 minutes.
Yes, madam. Am I audible?
Yes, sir. Yes, sir.
Okay.
Sir, shall we start?
Yes, madam. Go ahead.
Poonam madam, please start the recording.
Yes, ma'am. Am I audible, ma'am?
Yes, yes.
Okay, just starting. Done, ma'am.
Yes. Okay. So very good evening to one and all. Myself, Dr. Varsha Bhole, coordinator of this FDP, extend a warm welcome to you all for the 6 days online ATAL FDP on next gen computing, advances in HPC and quantum technologies for data-driven insights. On behalf of management, Honorable Principal Sir and Department of Information Technology of AC Patil College of Engineering. So very warm welcome to today's chief guest, Mr. Samrit Kumar Maitri, Joint Director and Scientist at SEDAC Pune, Dr. V.N. Pawar, Principal AC Patil College of Engineering, heads of the department, and all our dear participants present over here. Nowadays, the exponential growth of data and the increasing complexity of computational challenges have been ushered in new era of technological innovation, where the computational challenges have where traditional computing paradigms are being complemented by next generation solutions. High performance computing and quantum technologies are at the forefront of this transformation, enabling the breakthroughs in the field ranging from artificial intelligence and climate modeling to drug discovery and financial modeling. HPC systems are leveraging advanced architectures and parallel processing to tackle data intensive tasks with unprecedented speed and precision. While quantum computing offers the potential to solve the problems once thought intractable by classical methods. Together, these solves problem once Together, these cutting-edge technologies are redefining the way we derive insights from data, paving the way for future where science and industry are driven by more powerful, efficient, and intelligent computational tools. So, to cater to this need, today's FDP on next-gen computing, advances in HPC and quantum technologies for data-driven insights is organizing by Department of Information Technology, AC Patil College of Engineering, Kharghar. So, as we know, we all belong to rich Indian tradition where every auspicious occasion begins with the invocation of God. So, let's invoke the goddess Saraswati and seek her blessings. So, I call upon Professor Sampada Lokhande for Saraswati Vandana. Sampada madam, over to you.
Yes. या कुन्देदुतुषारहारधवला या शुभ्रवस्त्रारुता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्करप्रभृतिभिः देवे सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा. Over to you, Harshana.
Thank you, Sampada. Now I introduce a man of distinct vision and esteemed authority of today's program, Honorable Principal Dr. V.N. Pawar sir. Talking about his academic achievements, Sir has secured his PhD degree from the prestigious institute SGGS Nanded. Sir possesses teaching experience of more than 32 years. More than 30 national and international publications are his credit. His contribution towards the research grants from Airtel, D-Link and ERA are remarkable. His expertise spans digital image processing, robotics, and electronics communication. He is a great source of inspiration to us. We welcome you, sir. I request you to address the participants and over to you, sir.
Okay, thank you, madam. First of all, good evening to everyone. I extend immense welcome to all participant as well as chief guest, Sri Samrit Kumar Maiti, who is the joint director and scientist of CDAC Pune. Welcome, sir. Of course, I would like to congratulate Information Technology Department and their HOD and all staff for conducting ATAL faculty development, ATAL means AICT sponsored 1 week faculty development program on very advanced topic, which is next generation computing. Definitely, this will be learning approach to all faculties and learners, and it will enhance their skills with respect to teaching learning to the students. I am very happy to extend my heartfelt gratitude to the organizer of this program because of their meticulous planning and commitment to the making this event successful. I'm also thankful to not only our chief guest, but all resource persons who are going to participate and sharing their knowledge and expertise with us. And of course, all participants, because of their participation, healthy participation, this program will be very much successful. Of course, I would like to read one quote of John Davy when he said, "The education is not preparation for life, education is a life itself." As we begin this program, let us reaffirm our commitment to the lifelong learning and our mission to inspire the next generation. At the end, I wish you all a fruitful and inspiring week ahead. Let us this be a beginning of many innovative and uh, collaborative endeavors that will takes our institution to great height. Thank you. Over to Varsha madam.
Thank you, sir. Thank you, sir. So it's my great to have Mr. Samrit Kumar Maiti as chief guest for today's FDP. I take this opportunity to introduce the most versatile personality of today's program, our Chief Guest Samrit Kumar Maiti. Sir is Joint Director and Scientist at HPC Technologies, SIDAC Pune, and has been with the organization since 2006. As a part of National Supercomputing Mission, he is involved in porting, benchmarking, and technical support of scientific applications with his expertise on high performance computing, deep learning, machine learning, parallel distributed computing, and accelerator computing. He leads the team responsible for strategizing, implementing, executing, and supporting deep learning and machine learning application stack on supercomputing systems under National Supercomputing Mission. His team looks after Param Shavak Deep Learning GPU and Param Shavak Virtual Reality product development and deployment. Currently, he is leading a project on quantum simulator implementation on HPC system. His expertise includes high performance computing, distributed deep learning, machine learning, heterogeneous computing, accelerator programming, grid computing, system administration, and big data. We welcome you, sir. Please accept our token of respect and virtual token of respect and appreciation.
Thank you very much, madam. Thank you so much.
Although we are meeting in a digital space, our gratitude and enthusiasm remain just as heartfelt. We are truly honored to have you with us and look forward to an encouraging session. Over to you, sir. Now I request Samrit sir
Thank
to
you.
commence the session.
Thank you. Let me share the presentations, and then yeah, I will start talking.
Yes, sir.
Is the PPT visible?
Yes, sir.
Presentation mode.
Yes, yes, sir.
Okay. Thank you so much. First of all, I would like to congratulate AC Patil College, and this is an honor and privilege delivering this keynote talk, and I appreciate, I honor your invitation. It is an opportunity to share the talk, and it is an opportunity to share my experience amongst all participants, and that is why I am very much thankful to all of you. With due respect to Professor Vijay Kumar sir, and with congratulating all the participants here, I would like to start my presentations where basically I'll be trying to convey the message, and the message of evolving architectures, the message regarding evolving technological scenarios, the projects that we are working on, and also some of the challenges that we face while going forward implementing those technological aspects. My talk is supposed to continue for half an hour, but I think I have only 20 minutes left. So for some of the slides, I'll be going a little bit fast. If in case, by any chance, if you have any queries, you may write back to me, or if time permits, we may discuss upon here. I'm going to talk about HPC and quantum technologies. But when I was looking at the program, and as well as when I was actually looking at the thrust area of your FDP, um, by the way, can someone confirm? Am I audible clearly, madam?
Yes, sir, you're audible.
Okay, thank you. Yes, so when I was looking at The thrust area says advanced computing, where supercomputing, AI, and quantum computing all are included. And then the title says Advance in HPC and Quantum Technologies for Data Driven Insights. But rightly said, when we talk about data driven insights, we are basically pointing towards the current revolutions that are ongoing in AI machine learning. And very fortunately, I am one of the member in CDAC who is having exposure. I would not call myself as an expert, but who has exposure to all of these technologies, HPC, that is high performance computing, scientific computing, AI, and quantum computing. I have started my career with grid computing technology, which is again distributed computing technology was very popular in early 2000, and then slowly the world moves to cloud computing, and HPC has been always there. So, and then the all the sessions topics that I was going through, and I realized that the topics that has been proposed are advanced topic and quite interesting. However, I take these opportunities of 20 minutes to explain the basics so that you may possibly utilize the reference of this lecture while you are absorbing the knowledge of advanced topic which will be delivered followed by my session for next 5 days also, including today is 6 day FDP sessions. So again, thank you very much for attending my lecture. If anything not clear, please interrupt. We may discuss. All right. So basically, we'll be having introductory sessions on HPC first, how it works, because I assume, even though the topics are advanced, I assume some of you may not be having the exposure to HPC, their methodologies, working patterns, their architectures, orientations, organizations, etc. So I will just touch upon HPC, what HPC and the definition of HPC. Their working methodologies is very important because that cut across all other topics that I'll be discussing upon. And then we'll be talking about data-driven insights. However, I must inform all of you that data-driven insights here is a very limited topic in other sense, but here I would actually be discussing distributed deep learning. Okay, and then at the last sections, I'll be discussing on a topic which I'm very much currently working upon is called hybrid HPC quantum system development. So this is what the overall plan. Now, when you look into high performance computing, which is basically the domain of supercomputing development, design, and implementations. And when we say that, as the definition says, high performance computing, we are always aspiring to the higher performance from the current level. So it's a relative definition. It is never a static definition. Yesterday's high performance computing system is not today's high performance computing systems. The systems that we are designing today would be delivering high performance tomorrow. That is how it moves. So we basically utilize different kind of technologies. We do not only say that this is the only technology for high performance systems building. No, supercomputers were built. Today it is under building process, and tomorrow it will be built by different type of technologies. And these supercomputers would evolve over time as per the requirement from the domain scientist. I'll be talking about domain scientist role here also a little bit to give you a perspective that high performance computing domain is not only a technological domain, it's a cross domain technological and scientific explorations, and it's a very collaborative field where scientists come together with technological experts, and then they explore an uncharted horizons in scientific domain. And be giving one or two example of such, and there are very good case studies there. So technically it is never stable, it is always evolving, and the aspirations is always higher and higher. So we are never satisfied with the level of performance that we are getting at this point of a time. And slowly, as the technology moves, as the world is evolving, the definitions of high performance also getting changed, where high throughput is also becoming a part of high performance, because eventually the high throughput would also enable high performance. So it has also a direct effect into the high performance of your system. And that is why there is no standard definitions but an understanding of what high performance computing systems. Now, when you say high performance computing systems, we are talking about a systems which may be on hardware. But what is the use of it? What is the use of a supercomputing system? If you look into, there is a prominent effect of HPC and its associated technologies in scientific domain. For exploration of a science, the domain or the scientific fraternity has moved long back to scientific computations, scientific simulations, because they understood that everything cannot be explored in lab. Okay, so there are so many natural phenomena that has to be simulated somewhere, and when the digital systems came forward and proven its ability to simulate a lot of things, the digital system itself, and to be very specific, an HPC or a supercomputing systems has become, I would say, the next pillar of support to scientific fraternities for all kind of explorations. And to prove this 2024 Nobel Prize, in fact, there are two cases in 2024 itself for HPC, but I would mention one of them, and the other one is for your explorations and understanding and your interpretations. The first one, David Baker, who won the Nobel Prize in 2024 for development and inventions of a new protein simulations technology on a supercomputing system. So he extensively used a supercomputing system. The early one, where Martin Karplus, he won Nobel Prize again in 2013 for the development of a multi-scale model for complex chemical systems. So when I say multi-scale model, it is basically a scientific simulation software. So why I'm talking about it is scientific simulation software is the primary candidate for supercomputers, be it weather forecasting software, be it chemistry simulation software, genomic simulation software. All these are falls under category of scientific simulation software. These are the primary softwares those runs on a supercomputing systems, and these software is not possible to run them on a normal grade systems. And for your information, they are under development all the time. Some of the softwares are 20 years old. Some of them are recently coming up, but majorly they're quite an old set of softwares, and they are evolving because new technology and programming languages are coming up. To give you a brief, how it actually works. If you have a real system, you make a model. It can be a mathematical model. Is there somebody interacting for a questions? Madam, can you help me, because I'm not able to see the chat window.
Yes, yes. Lakshmi ma'am, do you have a question?
Okay, no problem. So let us move ahead. So we have a real systems, which is a natural phenomena, and then we make a mathematical model of it. Out of that, we do apply a lot of theoretical understanding of it. We also do a lot of experiments in lab. But there is another way of doing experimentations. We called approximations through simulations. And all these approximations through simulations is the most, I would say, less costlier way or cheapest way of doing an exploration, scientific exploration, and that is why this is very much preferred nowadays at initial level. So for drug discovery, you want to screen thousand of molecules. How do you do that? You cannot do, you cannot physically and feasibly perform it in a lab. It is too costly to do so. So thousand of drug molecules could be screened for their prospects on a scientific simulation software on a supercomputing systems, and that gives the input to the next level, right? That is how the overall simulation works. And if you look into the weather forecasting applications, what it simply does is it divides a domain. It considers a base domains, and it divides it into cubes. And for each of the cubes, you have set of parameters. and those parameters encapsulated into some data structures would basically referring to our data points, and these data points would interact with the other data points. That is how the whole weather domain, we call weather domain, which is an area which could be, let's say, 1 kilometer, or sometime in most cases it is ranged in between 70 kilometers to 100 kilometers. So there, one data point represents that distances in one directions. So that is how the whole domain is divided, and then data points are created. Once the data points are created, as you can understand, that it actually represents some kind of a matrix. That matrix, again, as it is very large, would be divided into sub-matrices here. So this process is called domain decompositions. We can call it as a data decompositions, but it is a domain decompositions in terms of scientific computing. So once that is done, it is basically you'll be trying to look into how these subdomains could be sent to a parallel computing system, how these subdomains could be sent a parallel computing systems, and multiple computing node would be doing their respective simulations workload part and sending back the final results to master node. This is how a master slave kind of a computation. The supercomputing working pattern, parallel programming working patterns, is an itself is a subject. I'm not going to go into much deeper form of it because of lack of time. So, in a very basic sense, that is how data decomposition works, and that is how a distributed computing platform works. In case of supercomputing platform, which is we can call it a subdomain of a distributed computing system, so the whole infrastructure is located at a single place, most of the cases, and they are very tightly binded, which means that once you access this particular master node, in most cases, because of the software and things, you would feel that you are working on a single system. You are not working on a very big, large cluster, because the compute nodes may range from 100 to 1,000, sometimes 30,000 on a compute facility. So you basically access these systems, and these systems are shared systems. So that is how you distribute the data, and then it basically compute in a divide and conquer methods, and there are so many other ways of doing that. Now, when you say data-driven insights, now how come these advanced technologies of supercomputing platform evaluations as well as quantum computing systems, and in between the term data-driven insights comes up? So when I was studying and giving my thoughts into it, then I realized, oh, we are actually discussing about convergence. That means how a data-driven applications, maybe AI applications, DL applications, can take benefit of a supercomputing platform as well. And then I gave a talk on it maybe 1 year back or 1.5 years back. And there I talked about the exact same thing, that how modern day deep learning applications are taking benefit of an HPC platform. And why so? Because they have so much of similarities. If you look into a deep learning neural network, they are nothing but graphs. And once you represent them on systems, they are large matrices. And in modern time, in recent time, we are working on 70 billion parameters LLM models, 30 billion parameters, and recently 400 billion parameter LLM models. So that many number of parameters, data points, the computer system is supposed to handle for training purpose or fine tuning purpose. All right. So basically, they are matrices, large matrices, and you have to do so many operations in a fraction of seconds by using some kind of a computing platform. People may think, okay, cloud can do that. Yeah, but technically speaking, at lower level, it is some form of distributed computing systems taking benefit of the computation's power in order to complete the task. So that is what the overall the possibilities that deep learning, and it is actually happening in real world, that deep learning is taking help of lot of supercomputing platform for their fine tuning and neural network training as well. And why it is so? Because the large language models or large neural network models, they're inherently distributed, and they are very large to be distributed on a distributed computing platform like supercomputing platform. the benefit supercomputing systems gives is that they already have so many other applications. Those belongs from scientific simulations domain, and those software, their ecosystems, middleware, and libraries are very much matured because they are there for last 20 or more so years. So because of all these, a compute platform like supercomputing systems now becoming very much preferred compute platform for deep learning workload as well. And then yeah, I think I'm almost out of time. I will take another 5 minutes to go through the presentation. So in the next few slides, I basically talked about how the AI can help HPC and HPC can help AI. Basically, how this marriage, this convergence is happening between them. There are so many strong justifications, and that is how you would see lot many specific deep learning specific or LLM specific transformer model specific computing system like Cerebras, GraphCore, Sampanova. They call themselves as a networked computing platform. Okay, intelligent processing unit. These kind of a specific systems, they are very powerful, not generic supercomputing platform, but very specific supercomputing platform for some kind of applications are coming up, and they are very good for transformer model computations. So that is why here the few of the thoughts I'll be sharing these presentations, and these thoughts basically telling you that there is a very strong case for the convergence of HPC and AI. And on the HPC side, it's fully ready. It's a very mature platform. On the AI side, I'll be taking one point is called why AI is also very much preferred for HPC applications development. You see, HPC application starts with a basic boundary data we call base data, and then it do lot of scientific simulations, basically mathematical operations on that data, and in between it generates so much of data, right? And it takes a lot of time for it is doing the calculation stepwise manner. Now AI is coming into the picture, and the scientists are exploring the possibilities of integrating AI into this whole pipeline, okay, so that they can skip some of the compute intensive stages to save time and to bring out the output very fast. And that is exactly has happened for the next, the other candidate of Nobel Prize winner. If you remember that, the deep learning team from Google has won their applications development methodologies has won the Nobel Prize, and they also took the benefit of a distributed computing platform to run and execute large language models. So that is why it is becoming day-to-day basis. It is becoming a commonplace situation that most of the scientists who are working with large models has to slowly shift to distributed computing platform. This is what the overall things, but the challenge is, in India, amongst the engineering community, engineering fraternities who are especially working in the digital domain, there is less awareness about HPC systems, and that makes it very difficult, to work on them. Once they encounter HPC platforms, they get access to the systems, so they have to invest a lot of time to learn how HPC system works to take the maximum benefit out of it. What happens in HPC, the applications domain people, they are coming from the chemistry, scientific, computational chemistry domain, computational physics, astrophysics domain, etc., biochemistry domain, computational biochemistry. So all these people, they are domain scientists. They are not computer scientists. So they are not very well aware how to practice HPC, but they eventually learn by practicing. On the other hand, the HPC community, the computer engineering community in India, they are not very much well aware about what HPC systems is, and that is why keeps them away from exploring a distributed computing platform of such. So that is why I propose that more and more discussions on this kind of topic should happen, because the need is very urgent. And if you look into recent requirements, and there are so many requirements from the top class companies, including Nvidia, on the scientific computations, distributed domains, etc. So the scenarios, job scenarios is also improving. And the last one is HPC and quantum technology convergence. Now, these particular slides basically explaining how a quantum system works, why we are so excited and interested to put them together and make a hybrid system is this. We understand that there are some kind of an applications like VQE, variational quantum eigensolvers. Right now, this particular solvers solves the problem in a scientific way, or rather, I would say, scientific simulated way. This is a classical way of doing stage-wise simulations of a natural phenomena. But the natural phenomena is by itself is a quantum in nature. So they do not follow the way we do the digital calculations through matrices. They follow some other methodology. We can call it quantum mechanisms. So natural phenomena are quantum by nature. Whereas to simulate them, we take help of digital methods, and those methods are stage-wise methods, basically matrix manipulations, right? Matrices. Now, this can we bypass? Can we bypass? Why we would represent one method, which is quantum in nature, into a classical form? Can we explore the possibilities of simulating a quantum phenomena through a quantum computer, right? If we are able to do that, immediately there is a very, very high benefit, high dividend that we would get basically in saving the time. That means a computing systems which is hybrid in nature, HPC, QC kind of, would be basically taking benefit of the both the situations, right? The data processing, all other associated works, error correction, post-processing, pre-processing, state preparations of the quantum algorithms, etc., would work on HPC because they are very classical in nature, whereas the actual phenomena would be simulated through quantum systems. So that is why we are planning to do that. There is so many other advantages also. The primary advantage is that if we make a hybrid system, HPC and quantum, we will be able to realize quantum advantage also. And also HPC are playing a major role in simulating the qubits, a distributed quantum circuit executions. That is also the other way of looking at it. So here also the same case, HPC is helping quantum fraternity or quantum science, whereas quantum science is helping the scientific simulations applications to be faster on HPC platforms. So that is what there is also a very strong case that both these domains are converging with each other. Here in CDAC, we plan to do this. We plan to, connect supercomputing nodes with a single quantum systems, and we are working on a quantum reference facility. We plan to connect them, but it is not going to be that easy. We have a system called Param Siddhi, which is one of the largest deep learning supercomputing systems in India, which is located at CDAC in our office here. And we are building a reference facility also called Param Q. This reference facility will be connected to Param Siddhi. So that means we are creating a hybrid facilities where scientific simulations applications would take benefit of the quantum simulations. That is what the proposals. What are the challenges or what areas we have to be working upon? We have to work upon all these areas that I have listed. I'll not be going by line, but yeah, one of the very interesting area that I am working on is runtime development and software stack development. Somewhere in the middleware portions, I'm very much interested to work upon where the traditional middleware of a supercomputing systems could be modified or tweaked a little bit in order to take benefit of the quantum systems. What I wish that in for the next 6 days, including today, you will be keeping these particular presentations with you as a reference, and then you'll be exploring all other advanced areas that the other scientists and researchers and faculties are going to discuss upon. I would like to thank you all for attending my lectures and listening to me. If you have any questions, we may discuss or we may move forward next.
Yes.
Please post your queries or in chat box.
Okay. Yes. Let me see.
Poonam ma'am, do you have any query? Poonam ma'am?
Yeah. I think there is no questions. I'm not able to see any questions in the chat box. So, madam, shall we move forward next?
Yes, sir.
Thank you
Sir,
so much.
sir, can you unshare your screen?
Yeah.